Hello, Heron and Riverside Scholars. Welcome back to Quarter 2. This is Mrs. Majors. Today we're going to do Skill 10, Simplifying Exponential Expression. Okay? Alright, so you have a table over there. I have number 1 through 6 of the property. So all that to say, number 1 through 3, super easy. Number 4, 5, 6 might need some review. And then after we go through those property, we're going to do some complicated example and done with the lesson. So let's go over one at a time. So I have a to the m power times a to the n power. So those are the exponents are m and n. When you have a same base and you're multiplying with the same base, what do you do with the exponent? You add your exponents together, right? So a to the m plus n power. Why is that? Because there are m times of a multiplied together, multiply by a times a times a. How many times? N of that. So how many would you have total of a's? M plus n of them. So it should make sense. All right. So there's an example over there. 5 raised to the 2x minus third power multiplied by 5 to the 5 minus 4x power. Notice both of them have a base of 5 and we're multiplying. So what can I do with the exponents? I can add my exponents together to get 2x minus 3 plus 5 minus 4x, and then combine the like terms. 2x minus 4x is negative 2x, and then negative 3 plus 5 is plus 2. And I'm going to leave it like that for now. All right. Now, number 2, you have a to the m power divided by a to the n power. What do we do when you're dividing with the same base? We subtract the exponent. So a raised to the m minus n power. So here's the thing. I like you memorizing all the rules, but sometimes, you just want to take a little shortcut. So let me just quickly go over that with you. I'm going to give you an example. Let's say 2 to the third power over 2 to the fifth power. Technically, what do? You subtract it, right? So 2 to the 3 minus fifth power, and then 2 to the negative second power, and then all of that. Well, I don't really like you to do it this way. I mean, you can, but you're kind of wasting your time. Just take a shortcut. When you have something like that and you know the numerical value, 3 and 5, just take the bigger one and subtract from the top one. So I have 2 times 2 times 2 at the top. I have 2 times 2 times 2 times 2 times 2 times 2, whatever, 5 times at the bottom. So what would that be? Wouldn't it just be 1 over 2 to the second power? Because I'm just subtracting from 5 minus 3 and keep it at the bottom. So this is just a little shortcut you can do. Okay? All right, so let's go ahead and do the example over here. I'm going to take care of the numerator first and the denominator after that. So numerator, multiply with the same base, so I can add my exponents. X plus 3x plus 4, 4x plus 4. My denominator, 2 raised to the same base, multiplying, I can add my exponents. 2x plus x is 3x. 1 minus 5 is minus 4. All right, now what I'm going to do? Well, these ones, unlike the example I gave you here, they have the x in it. So I don't really know which one's bigger, which one's smaller. So I'm just going to go ahead and do 2 raised to the, subtract those. So 4x plus 4 minus 3x minus 4. I'm subtracting my exponent. Please remember that you got to put that parentheses over there. If not, you're going to make a mistake. I guarantee you. So 4x plus 4 minus 3x plus 4. Combine the like terms, 2 raised to the x plus 8 power is my answer. All right, third power, a to the m raised to the n power. So when you have a power raised to the power, you got to multiply your exponents together. So let's go over here. I have 2 raised to the third power raised to the x minus second power. So I'm going to multiply my exponents. 2 raised to 3x minus 6 power times. Over here, I just have it. Now what do? You're multiplying with the same base. I'm going to use the first property. With the same base, we're going to add the exponents. So I'm going to add the exponents. 2 raised to the 3x minus 2x is x. Negative 6 plus 2 is minus 4. Good so far? All right, now let's go. I told you 4, 5, 6 can be a little tricky, but not really. Now, what are you going to do when you have a negative exponent? Do you remember you kind of learned something how to like flip it over and then make it positive exponent? So that's what we're going to do. So when you have a to the negative n power, right now that's on the numerator, right? Because it's a over 1. What you're going to do is you're going to make it 1 over a. So put that the denominator and then make that negative n power as a positive n power. Or you can write it as 1 over a to the n power. It doesn't matter. Both are the same expression. So let's say, for example, I have 1 over 3 to the negative 4th power. What are we going to do with that? Well, 3 is in the denominator, so I'm going to move it up to the numerator and then make that negative 4 to the 4th power. That's what you will do. Okay? If you're wondering why this is, well, first of all, let's just do this one first. Okay, so I have 3 raised to the negative 2x plus 2nd power. I don't like the negative exponent, so I'm going to make it 1 over 3rd. But instead of this, I'm going to put the, well, when the negative goes up, that's same as multiplying negative 1, right? So I'm going to make it negative 2x plus 2, which is 1 over 3 raised to the 2x minus 2nd power. Okay? All right, so let me explain you why that is happening over here. So I learned this from my college professor, and I thought it was super duper cool. So let's go. All right, what's 3 to the 2nd power? 9. What's 3 to the 1st power? 3. Well, let's do one more. What's 3 to the 3rd power? 27. Do you see pattern how to go from here to here, here to here? All right, how would you go from 27 to 9? Wouldn't you divide by 3? Yes. How would you go from 9 to 3? Wouldn't you divide by 3? Yes. All right. Then what would be 3 to the 0 power? Wouldn't you divide by negative 3? Divided by 3? Yes. 1. Oh, okay. Now what will be 3 to the negative 1st power? Wouldn't you divide by 3? 1/3. What will be 3 to the negative 2nd power? Divided by 3? 1 over 3 squared, or 1 over 9. So these actually explain a lot of things over here. All right, one of that is when you have a negative exponent, do you see how 3 become 1/3? Negative exponent, 3 become 1/3, and then negative 2 becomes positive 2. So this actually explains that proper number form that we just did, what to do with a negative exponent. Another thing I want to go over is when you have a 0 exponent, what's always the answer? 1. There you go. Number 5, a to the 0 power, 1. So any number, I don't care. 1, 2, 4, I don't know. The 0 power is going to be 1. I don't know why I put the comma there. Okay? Alright, so let's go over this problem together, example together. I have 4 and 2. So what are you going to do? This is a little different than what we've been doing before, right? What you're going to do is convert that as a same base. Okay, so I have 4 and 2 and 2. What will be my common base? 2, wouldn't it be, right? So how would I express 4 as a 2? 2 to the what power? Second part would be 4, wouldn't it be? Okay, so let me keep everything the same. And now over here I'm going to distribute that in. So 2 to the 4x plus 4 times 2 to the x minus 1, 2 to the 5x plus 3rd power. Over here add my exponents together. 2 to the 4x plus x is 5x. 4 minus 1 is 3. And 2 to the 5x plus 3. Well, it's the same thing, so it's actually going to be 1. But you can also think of this as a subtracting my exponents, right? Because you're dividing. Which is going to be 0. That's why it's going to be 1. Okay? Alright. Now, number 6. What do you do with the fraction exponent? Alright, here's the thing. Your denominator becomes the nth root. And that, numerator is going to become the power, the exponent. So it's going to look like this. Nth root of a to the n power, or nth root of a to the n power. Same thing. Okay, so once again, review. Denominator becomes the nth root. Numerator becomes the power. Got that? Okay, denominator, nth root, numerator, power. So that being said, let's go over this one together. We're going to take care of that square root at the very end. So let's take care of the inside of it first. Alright, I have 3 and 9 as my bases. What should be my common base? 3, right? So instead of 9, I'm going to write it as a 3 squared. And I distribute that. So 3 to the 2x minus 8 power. And then I'm going to add my exponents together. 4x minus 6. Good so far? Alright, now what I'm going to do. Remember, the nth root becomes the denominator of the exponent, right? Well, over here it's a square root. So what do you guys know that that's actually 2 over there that's hidden there? Yes. So that's going to become the denominator of my exponent. So it's going to be 4x minus 6 divided by 2. That's the thing you have to remember. That nth root, square root, becomes the denominator. And then now I can just simplify my exponent there. 2x minus 3 is going to be the answer. Okay, all right. Please do next few problems and then come back to the second video.